All right, favorite time of day, time to get a new lesson. Woo! Here we go. The top of your screen, top of your paper should say 2-6, add and subtract unlike fractions. Now, you're probably saying, whoa, whoa, whoa. We didn't do section 4. We didn't do section 5. Yeah, you're right. I'm kind of skipping around here. So bear with me, but I think it'll just make a lot more sense if we jump to section 6 and make sure we've got that down, and then we'll come back and hit 4 and 5. Okay? All right. So adding and subtracting fractions with unlike denominators. You've done this before. We're going to do it again. And the part that we're going further and faster and deeper with is the fact that we're going to have positives and negatives as well. So learning target for today, I can add and subtract fractions or rational numbers. I'm going to use fractions today with unlike denominators. Okay. So we've got to do some work, just like you did in that second section where we had comparing and ordering. So we were working on getting some common denominators. The same thing here today. I'm sorry, I'm kind of sloppy. Okay. Clearly I need my lunch break. Kind of hungry. If you hear my stomach growl, sorry. I've been trying to snack a little so it wouldn't happen. All right, so that's what we're doing today. We're going to add and subtract fractions that have unlike denominators. So a lot of this is review. And like I said, we're going to throw some positives and negatives in there at you. All right, here's your first example. 1/8 plus 2/7. So the first thing I want you to start thinking is eighths and sevenths, eighths and sevenths. You know, really, if you look at those two and you ask yourself, do they have any common factors at all? Or are they, in fact, relatively prime? Yeah, there's no common factors at all. So really, one of the fastest ways you can find that common denominator then is just simply multiplying 8 times 7, saying 56. This is actually going to be the very first least common denominator for these two. All right, so 1/8. When I turn this into its equivalent name in 56ths, this becomes 7/56. 2/7, I have to multiply the top and the bottom by 8. So 8 over 8, which is 1. That gives me 16/56. Okay. Now that I have a common denominator, you know that that's going to be your final answer. Ugh, that's messy here. 56ths. I should erase, but it's a pain to get at the eraser right now. So make this 23/56ths. I should have stopped for a moment and said, hey, is that in simplest form? Look at it for a bit. It is. So you're done. Cool. What if you have something with mixed numbers? All right, so here's what I'm going to say. If you're adding, and we're adding mixed numbers, here's what I do. I just really hate doing things horizontally this way. I'd rather do my fractions vertically. So I'm going to write it like this first, okay? 2 1/6 plus 3/4. Now, please do not forget this whole number. So I'm going to write the 2 right away. Now, 6 and 4 share a common factor of 2. And what that tells me is, you know what? I'm going to go up here and make my list of multiples, okay, and kind of go from there. Now, really, 6 times 4 is 24. I could use 24, but there's something that's going to show up that's going to be smaller. My least common multiple really is 12. So I'm going to use 12. Here we go. 1/6 is the same as 2/12. 3/4 ends up being the same as 9/12. Now I have common denominator. Now I can complete the problem. I happen to have 11/12. My whole number is a 2. Sweet! Done. That is in simplest form, so you can move on. What if I'm subtracting? Now you can proceed like you normally would, but you know what's going to happen here? Well, let's just get into it here. 6 and 8. Now you could use 48, but they do share a common factor of 2. And so I'm going to tell you, let's find that first common multiple. 6, 12, 18. Actually, we should use the largest number first. We'll find it faster. 8, 16. Nope. 24. There we go. Alrighty. So this would be 1 and 4 24ths. This one is going to be 1 and 15 24ths. And you're subtracting. Ooh. Now, there are a number of ways we can approach this, but here's what I'm going to recommend. I think it'll be more foolproof. The numbers get a little clunkier, but I think you're less apt to make a mistake if we just say, change this back into an improper fraction in order to do the subtraction, okay? 1 and 4 24ths. If I change this back to an improper fraction, remember how you do that? 1 times 24 plus 4 more. This is 28 24ths. This one, 1 times 24 plus 15 more. This is 39 24ths. Okay? This is really the problem you have now. Okay, now I know my final answer. I'm going to do a little bit more work here. I was going to say it's going to end up being in 24ths, but I might have to do some simplest form work here. Okay, so first I'm going to say this. Come down to the side, and really this is the problem you have. 28 minus 39. That's really the problem you have. These are the numerators. 28. Every subtraction problem is like adding the opposite. So keep 28, change it to addition, take the opposite of 39. All right, now we're cooking. 28 and negative 39 mean I'm going to end up with negative 11. Negative 11. Then ask yourself, okay, simplest form, they have a common factor. Nope, you're done. My answer is negative though, so watch out for that, okay? So when you have some mixed numbers, I'm just going to recommend, gosh, why don't you just make them improper, do your subtraction, and then we'll continue from there. I think it'd be less apt to make a mistake. All right, let's look at this example. Evaluate this algebraic expression 5/9 minus h. And h has a value of negative 7/12. The first thing I do is rewrite this algebraic expression by substituting in the value for h. Now look what I've got. I'm subtracting a negative. Subtraction always means the same as adding the opposite. So keep, change it, switch it. So negative 7/12 will become positive 7/12. Okay, that looks better. However, I don't have a common denominator yet. So let's do that. 9ths and 12ths. So what I would recommend off to the side is just start thinking of your multiples of 12. 12, 24, 36, 48, 60, and so on. Okay? Then ask yourself, can 9, if I start doing multiples of 9, 9 go into anything in this list? Find the first one. 18, 27, 36. Whoa! The crowd goes wild. Nice. You could multiply 9 and 12. I'll tell you, that gives you 108. That's a pretty cumbersome and large denominator to work with. I'm not saying it's wrong, but I'm saying using the first or the least common denominator is easier. All right, let's convert these guys. 20 36ths is the equivalent of 5/9. 7/12 becomes 21 36ths. Okay, you have a common denominator. Now simply add the numerators. So we get 41 36ths. Okay. However, a lot of times in algebra we'll say, you know what, this is an improper fraction and you can leave it that way. Or you can go ahead and turn it back into a mixed number. 36 can go into 41 one time. You say, how many will you have left? I believe it's 5. Final answer. And 5/36 is in simplest form. All right. It's a lot to handle, huh? Let's look at one more. 3/5 plus negative 2 2/3. Ugh. All right. Now, this is positive, this is negative. I know it's an adding problem, but I'm going to tell you this. The first thing I want you to do, I think it's just going to be a lot easier for you. If we change 2 2/3, the mixed number, into an improper fraction. So let's do that. 2 times 3 plus 2 more would give me 8/3. Okay, so I want you to think of this as the fraction 3/5 plus negative 8/3. It's an adding problem. Don't switch anything, but we do need a common denominator. So fifths and thirds, there's no common factors there. So just take 5 times 3 for 15. That's what we're going to use each time. Let's see, 3/5 becomes the equivalent fraction 9/15. Negative 8/3 is going to become the equivalent fraction negative 40/15. Notice how I took that negative sign now and I'm putting it up in the numerator. My denominators are the same, so I have 15ths here. And then you just need to take and add the numerators now. 9 plus negative 40. Your final answer should be negative 31. Now, I'm going to tell you, 31 and 15 share no common factors. So it really is in simplest form with regard to being relatively prime. I'm not going to be a stickler about changing this back into a mixed number, really. If you left your answer like this, I'd say that's good. However, changing it into a mixed number, you simply have to ask yourself, how many times does 15 fit into 30? And it would fit in there twice with 1 left over. Don't forget that this is negative. I would accept either one of those answers, okay? Sweet. Last one. Here's a word problem. Don't let that freak you out. Simply decipher what it's asking you to do. So read through it. 2 dancers are making necklaces from ribbon for their costumes. They need pieces measuring 13 3/4 inches. I'm going to circle that. And 12 7/8 inches. How much ribbon will be left over after the pieces are cut from a 36-inch length of ribbon? Okay, so first things first is we need to add these two together. 13 3/4, 12 7/8. I got to add these. All right, now, because everything's positive here and we're adding, I'm not going to switch into an improper fraction. This one, it'll be okay. If you wanted to, okay, but you're going to have awfully large numbers. I'd say keep 12 and 13 and let's just deal with 3/4 and 7/8. The nice part is 8 is a multiple of 4. So when I go to get a common denominator, I can simply use 8, which means my bottom number is going to stay the same. Just turn 3/4 into eighths and I get 6/8. Okie dokie. Now we just have to add. Awesome. 6 and 7 is 13. Add the whole numbers now. 13 and 12 gives me 25. Now, I just told you on the last screen that I was fine with leaving an improper fraction, but not right now. This is not okay. 25 and 13/8, that just really doesn't make sense. Keep the 25, and then let's deal with this 13/8. 13/8 can be written as this mixed number. 8 can go into 13 once. You'd have 5 left over. Now, get this squared away or simplified and written back together. 26 and 5/8. That's your final answer number-wise, but don't forget, this is not done yet. This is just the inches that I need for the necklaces. I'm not done because, see, it said how much will be left over after these pieces are cut out from the 36-inch length. So we really need to take 36 now and subtract 26 and 5/8. Now, notice I'm writing this vertically because I need you to see something here. 36 doesn't have any fraction of eighths here. So just like you would if you had decimals and there was nothing above, you'd put a 0. I'm putting 0/8 in there, okay? All right, now, whenever you're subtracting mixed numbers, you do the fractions first. 0 minus 5, can't do it. You can't do it. You have to borrow. So we're going to borrow one from 36, which will make this 35. And the one that you're borrowing, I'm writing it up here, it doesn't become 10 because I need to turn this into a fraction in eighths. 1 is the same as 8/8. Oh, so that one we borrowed is the same as 8/8. We're in eighths land. That's why I had to do that. Because see, now when I take 8/8 and I want to subtract 5/8, I can do that. 8/8 minus 5/8 is 3/8. But I no longer have 36 here. It's 35 because I borrowed that one whole to turn into 8/8. 35 minus 26 is 9. All right, what on earth is 9 3/8? What am I talking about in this problem? It's ribbon, and specifically inches of ribbon. This is what's left after you cut those pieces out for the necklace. That's kind of a lot. So here's what I want you to do after you've gotten through all of this. Your assignment for tomorrow is to look into Schoology, see what it is, or if you're in the classroom, look up at the whiteboard in the front or the back of the room. It also has it on there. And go ahead and get started. And as always, may the force be with you. Good luck.